think the first thing to consider with this
Yeah.
is kind of the numbers of stars, the number of civilizations out there, right? The potential number. So this is like the Drake equation.
Yeah. Okay. Yeah. So the Drake equation's built of like all these different components, going from like rate of star formation, rate of number of those stars that form planets, number of those planets that might be able to sustain liquid water, number of those which the origin of life. I mean, the numbers get smaller and smaller. Obviously, that's the point of it. You're trying to filter it down to like come up with a reasonable estimate for the number of civilizations.
Yeah. And it's all just conjecture, as in almost every number, largely every number that goes into that thing ends up being mostly conjecture for the kind of biggest questions.
Yeah, for the latest parts of it. I mean, the earlier parts like star formation and even planet formation, we're starting to get some sort of a bit more like numbers on, and even planets in the habitable zone or planets that might be of a temperature range that could sustain liquid water. We can start putting a bit more like a narrow error on that now. Yeah. Now we're getting information about exoplanets and stuff.
There was some percentage of stars they think now contain a planet in the habitable zone, which is kind of like a not really great concept anyway.
Yeah, it's not. It's a bit shaky.
But it's something really high, isn't it? Like the proportion of stars that it's something like 10%.
It's up there. Yeah, it's like 10.
I can't remember the exact number.
Even might be 20. I mean, it's really high. It's a really high number.
Much higher than you would think.
But yeah, as you said, that concept is a little bit like...
Yeah, it's a bit shaky because things like ice worlds and stuff, or moons, or these sorts of things that might have life, but they conjecturally might not have life as well.
Yeah, I mean, it might turn out that the most common like habitable world in the universe is not in the habitable zone. It might be like icy moons or something, or like much more common and much more frequently habitable. It might also turn out that that's not the case. We just don't know at the moment. But certainly we'll be able to tell more and more about that, like the early parts of that Drake equation. So like the planet formation, star formation, all that stuff. But then the later parts of it, like how many planets support the origin of life? Of those, how many develop complex life? Of those, how many develop intelligence? And then you get into the like how long do they last, and how long are they broadcasting signals for? Because what the Drake equation like is ultimately trying to tease out, and what we're kind of interested in here is how many civilizations there are in the galaxy that are communicating, that are detectable.
Yes.
Right. That's what the Drake equation is specifically aimed at doing.
And if you think about our own like sphere of radio waves since we've been broadcasting, that really hasn't covered that many stars. I did a while ago see an article, and I can't remember which newspaper it was in, and they were basically saying their question they posed was like, if ET's out there, like in kind of a, why the hell haven't they kind of communicated with us yet? Like, where are they? Yeah. Because and then making this thing that we've been sending out signals for 80 years. What the hell's going on? And it's kind of like, that's only reached maybe like 10, 20, 100, maybe a couple of hundred stars by now. I can't remember.
Yeah, exactly. Maybe not even that many, to be honest. I mean, if you got like a scale map of the Milky Way and you draw a sphere around the sun of 80 light years, is absolutely minuscule.
Oh yeah.
It's unbelievably
you can't see it
tiny.
If you have the Milky Way out and you can see, on like a piece of paper. Yeah. You can't. It's just basically a dot. It's just a pinprick on there.
Yeah. And like even like stuff like the Kepler telescope, which is looking for exoplanets, is looking like 1,000 light years away. And even that, like the cone of that if you see that like projected onto a map of the Milky Way, is unbelievably small.
Yes, it's really small.
Yeah, I mean the signals that we've been sending out in terms of like just like general radio and stuff for 80 years or however long. Has not got very far. No.
And consequently, say in 100 years we nuke it ourselves.
Yeah,
it's possible.
Or
something like
something
that.
Happens.
Something kills us all. Then those signals will have only reached X number of stars for only a small number of stars for a period of time. And the signals will get weaker and weaker, and then those signals will die out as well. So there'll only be like a sort of sphere of a certain thickness that expands out into the universe. And if nothing is around, any civilization isn't around for that incredibly short period of time, no one's going to detect it. So basically, it's very hard to kind of. Those are the kinds of things that get built into the Drake equation.
Yeah, and that time thing is I think is the last term in it. Is like how long are they broadcasting for?
Yes,
and that's like the last denominator or whatever.
So for example, we could have already had on Earth in its 200 million years ago a bunch of like radio signals come for 1,000, 2,000, 200,000 millions of years potentially from an alien civilization that then destroyed itself. Yeah, and we missed it.
That's a cool thought.
So they could have already washed over Earth those signals, and
like the dinosaurs like bathing in alien radio signals, and without knowing it.
Yeah,
That would, I mean, that's a cool thought, but it would also kind of suck real hard.
I know, yeah. So there's a lot of reasons why there's not much chance.
But having said that, you can make estimates based on that Drake equation. So the point of the Drake equation is not to give you an answer, really. At this point, it's not really to give you an answer of how many. It's more to like try and identify the things that we need to know in order to give us an answer. But people can like put in imaginary numbers into it and come up with results.
Some half imaginary, half sort of based in fact.
Like educated guesses at some of those later things. And even if you put in some really, really, really like conservative estimates on how many planets might have the origin of life and of those, like how many would be stable long enough to evolve complex life, ignoring all the other factors that might be involved in complex life. Even if you do that, you still come out with numbers that are like, well, I mean, it ranges between something like 1,000 and 100,000 or a million or even more civilizations in the Milky Way that should be broadcasting.
Although one of them didn't we find one of them that was like a mega low estimate? Yeah. What was the number? It was like 10 to...
Yeah. I mean, this one was just an example of how you can really play with this equation and get it to tell you whatever you want.
Yeah, exactly.
But the number it came out with was like... I mean, they were really going to town with these estimates. I mean, they were arguably unrealistically low. I mean, we have no fucking idea, obviously. No. But like...
Yeah, but these are right at the bottom of the estimate.
Yeah. But the number it came out with was something like 1 times 10 to the minus 12. Right?
I thought it was minus 17.
No, it's minus 12. It's minus 12.
Yeah, that's
pretty small.
Pretty small.
So that's like 0.12 zeros 1. No, 0.11 zeros 1.
Zeros.
And that obviously that number is how many civilizations there are in the Milky Way. So or per galaxy, basically. Yeah. So which could mean that there's only 1 or 2 in the observable universe.
Yeah, because there's like 10 to 11 galaxies or something, is it? Something like that. Like 100, 200 billion or something like that.
In the observable universe, yeah.
Yeah.
So that would be 100 billion would be 10 to the 11.
Yeah.
Yeah. So if there's basically one civilization for every 10 to the 12 galaxies, then we could be the only one in the observable universe.
Yeah.
If you take that interpretation of the Drake equation.
Yeah, and also even then we're still hugely unlikely to have appeared in a sense. We are obviously here.
We are that.
We're a fluke then.
In even 1 trillion chance, basically. Yeah. Which is mental.
Pretty depressing.
And actually, if that's the case, and this question, what are the chances of detecting it, is basically there is no chance. See you later. Let's just go and sod the rest of this show. So let's work on the basis that may be not the case.
Yes, we'll work on the basis that there's a lot of different estimates. We don't really know exactly how many there could be.
Yeah.
But we are looking with a number of different techniques, right?
Yeah.
So firstly, we're just listening.
Yeah, listening to radio.
So things like this giant, Arecibo telescope, these kinds of things, are basically just sitting there absorbing all the radio data, everything that's coming into Earth, and hopefully they're normally piggybacking on the back of other work as well.
Yeah.
And there's a lot of data they got to sort through.
Yeah.
But they're essentially just sitting there waiting quietly and listening.
Yeah, it's one of the problems, isn't it, that these telescopes don't get time to really just do dedicated searches so much, and they tend to be doing radio astronomy, I don't know, listening to stars and galaxies and stuff, and then the SETI people, the intelligence searching people would just sift through the data later.
Yeah. Well, so the SETI at home thing, compute thing. Yeah. I guess we'll talk about this a bit more when we talk about breakthrough.
Yeah.
Well, we can talk about that now if you want.
Yeah, why not? We'll move into it.
But so the SETI at home thing basically computes all this data on a cluster of different computers. I got it on my computer recently, but because after that, you remember that news about the kind of strange star system that had might be a cluster of comets.
Yeah.
And I got really excited about that, and obviously,
same.
Stupid. I knew it was almost never going to be an alien Dyson sphere or something. We'll talk about that in a sec. But I still kind of got that feeling that, hold on a minute, it's probably a very high chance that I'm going to die never knowing the answer to this question. And so I was depressed by that, so I downloaded the SETI.
It's maybe I'll find it.
Maybe I could chip in a bit.
We used to run that when I was a kid on my parents used to run it.
Yeah.
Yeah, back in the day, it was probably processing about like a millionth the amount of data than it is now.
Yeah.
But that's the cool thing. So that what you just mentioned, the Breakthrough Listen project, which is like how much money did you put into that? Like 10 million or is it 100?
I think it was 100 million over like 10 years or something.
Decent.
So not bad. But a lot of that is going to go on high performance computing.
Yeah,
stuff.
Which is good. I mean, that's sort of
which is
arguably what's needed more than telescope time.
Yeah, because surprisingly, actually, we need a huge amount of stuff to process. We've got a huge amount of data that hasn't been processed. Yeah. And consequently, we need a way to crunch it, to get through it.
They are though buying like 1,000 hours of dedicated telescope time as well.
Yes, which is going to
some of the massive telescopes.
Yeah, it's going to increase the amount of like observed time on these different instruments over like 10 times more than it's been done before in its entire lifetime of SETI. Yeah. So it's going to be a hugely like a big deal. Yeah. So I mean, there's a possibility that might bring something, and so that's one way. It's just listening. Which is it's not just radio though.
It's not just radio. Yeah, I was going to say. And even the Breakthrough Listen thing is going to be looking for optical signals, isn't it? Yes, it is. In fact, it definitely is.
I think it is.
It's going to be focused on the galactic center to look for optical signals. I know it's going to be doing that.
Why are they doing that?
Because there's this argument. And we can go on to this a bit more in a minute about the kind of things you might expect. But there's this argument that advanced aliens that have developed AI essentially.
Right.
Their civilization will essentially be run by super intelligent AI, and that these things will hang out in high energy density areas like the galactic center.
Whoa.
So they're going to look at the galactic center with the Breakthrough Listen project.
I always thought like towards the galactic center. Obviously, that's true if you're just seeking out energy, but like it's just going to be full of horrible like stars smashing. The further you get into the middle of it, the like more messy it gets, the more energy that's being flung about.
Yeah, but so you're talking about a civilization that isn't bothered by that.
Yeah,
like their technology is such that it's fine. It's like they can just handle a bit of it's like it's just have like the equivalent of like an umbrella. Like it's raining a bit. There's a bit of like there's a bit of black holes and supernova going on.
Yeah,
like,
just build just get your black hole umbrella out. Deflect that stuff. Get rid of that nasty gravity.
That's not the core of the project, obviously. Like looking at the galactic center, I just thought that was kind of cool.
Optical stuff's like lasers and stuff.
Yeah, like directed light, like optical visible light, essentially.
So that in that case, they'd have to be pointing their kind of transmitter directly at Earth, right? If it's a laser, obviously lasers spread, but they don't spread as much as like a sphere of radio.
Yeah, I guess the function of them would be to almost like short range. If you're like, say, you want to send a signal to like a satellite that's in your solar system, it might be quite a good way of doing that.
That's that's true. That's
like,
true.
Boop, instead of like flooding everything with radio signals.
Yeah. Or wasn't there like some idea to like shoot a laser at a kind of like satellite spacecraft thing to try and give it power? Was that a thing?
That rings a bell, actually. I think that's different.
Yeah, it is. But like that might be something you incidentally pick up.
Yeah.
But we're thinking about something that's almost like directed out to try and get maybe directed at us because someone else has picked up something else.
So say like some other civilization has their equivalent of like the Jimmy Webb Space Telescope.
Jimmy Webb. The James Webb.
Jimmy W. And they've noticed that there's a planet out there that's got like some weird chemical disequilibrium in the atmosphere, like shitload of oxygen, even like some tasty looking like chlorophyll in the spectrum.
The red edge.
Yeah. And they're like, let's see if they're up for a chat, and then they fire some lasers at us. Yes. So that is that kind of thing, which I guess is a bit of a long shot. I mean, the chances of that, but then you never know. Like that might well be happening.
Yes, exactly. But you've got to look to find that. You've potentially got to look in very much detail, a big survey of the entire sky.
Yes. Which is why this Breakthrough Listen thing is going to be good, because they're going to be able to sift through a lot of data that's coming off of other telescopes anyway to be able to try and do that.
And they have more time on dedicated stuff.
Yeah.
So I guess on that note, like looking for like bright points in the sky is a bit like looking for. So the other thing you can do if this stuff's not communicating or isn't throwing out radio signals, or at least we haven't detected anything like that, you would look for kind of. Well, you'd look for exoplanets, I think, to start with, right? That would potentially be habitable.
Yeah.
Or you could look for direct kind of evidence of a civilization.
Sort of like that thing we were talking about earlier.
Exactly.
The thing that everyone was calling an alien megastructure for a while. And that's cool.
And it might be.
It might be. It's unlikely.
It's looking less and less likely.
I think
nothing related to it. SETI have stuck a bunch of radio telescopes.
Yeah, and some more observations from Kepler or whatever have been like consistent with the comet theory,
right?
Which is still mental. I mean, that thing, like, this is a bit of an aside, but that thing was like blocking out whatever it was moving in front of the star, was blocking out like 20% of its light. And considering that normally up to 20%, and considering that normally like planets that transit in front of stars block out like 0.00001% of the light or something, even like massive Jupiter-sized planets.
Yeah.
So like, the fuck kind of comets are that?
It might be like the tails kind of like spreading out behind them, and that's blocking our view, if you like. So it's like comets going in, and there's kind of like a huge cluster of them. Yeah. And there's like a huge amount of tail coming off, and it's kind of smearing. Yeah. It still seems unlikely.
Yeah, but there was something weird about like there wasn't any kind of infrared. Like, would have expected loads of infrared stuff because of the dust being like heated up and.
Was that from comets? Was that from a planetary breakup?
Yeah, maybe. That's true. That's a bit different, I guess. I don't know, but I have read that like basically the alien megastructure thing, obviously, it was a bit too good to be true, and it's not true. Sadly. But anyway, that kind of thing, so like big engineering things, structures, whatever, might be detectable if they're like absolutely massive.
Yeah, I mean, you're talking about stuff that's like unimaginable for us to build at the moment.
Yeah.
Like things like the Dyson Sphere. So if you've not heard of that, that's just like a Dyson Swarm, which is kind of like a giant structure that surrounds a sun that's basically used to collect the sun's energy.
Yeah.
You could potentially detect something like that.
Yeah.
Or
I'm still not convinced. I mean,
I'm not convinced. I'm not
convinced by it. Like, surely something like fusion power is a better way of getting energy than just like rigging up a load of solar panels to a star, like in a huge swarm around a star.
Yeah,
you'd have to like dismantle an entire solar system's worth of material to build something like that.
There's those what they call the type civilizations. So like
the Kardashev type.
Kardashev.
Yeah,
and. Isn't type 1 is basically like a civilization that's sat on Earth and uses fusion power or whatever, up to fusion power. It uses all the energy, doesn't it?
Yeah, I don't know if it specifies fusion power, but it's like basically,
no, it doesn't
basically it's using like all of the energy that's available on the planet.
Yes. So then
so that you can't really, your civilization can't expand anymore because it's limited by the power that's available, energy that's available on the planet.
So by extension, then, if you have a greater energy demand, you might go and build something like a Dyson Sphere around the sun.
That's the argument. That's the argument.
I still would kind of agree that I'm not sure. I'm not quite sure why you'd ever need that much power, but then I guess maybe it's again one of those things they want to build like a huge computer that does whatever.
Yeah, and they just have a bigger and bigger civilization. Like, they've got the means to spread and multiply, and so why not do it? Like, they'll probably be colonizing other planets and whatever. That's true. And like, if you can just like centralize all your power production to like a giant structure around a star, then do that. I mean, I don't know. The other possibility, right? And this is a bit slightly wackier.
I like it.
But it's just that like, you know, like humans throughout the whole history of humanity have been like just building stuff for the sake of it, like huge, like just like
tallest building,
the tallest building, or like, you know, look back in the ancient civilizations, building huge like pyramids and stuff. I mean, that's all kind of religious, but what I'm trying to say is like intelligent civilizations don't necessarily have to have like a direct benefit reason for. If you have the ability to build a giant thing around a star, maybe you just do it for the sake of it, for other civilizations to stumble across and be like, what the hell is that?
Just like a sort of conquering nature thing,
kind of.
Yeah,
I mean, I don't know.
I mean, you'd have to be in a kind of such a comfortable state of civilization that it would just be a thing that would be okay to do.
Yeah.
But it's almost unimaginable what that far in the future kind of holds.
Yeah, sure.
You might be totally disinterested in exploring anymore because life is just kind of so comfortable, and because you can sort of simulate everything, you might just like lose. I mean, that's another reason why maybe you haven't seen anything, because everyone just loses the kind of.
Yeah.
We'll talk about that in a bit in the Fermi paradox, but
and there's other things like you can imagine, like maybe
like giant halo sort of looking structures.
Yeah, or even maybe civilizations decided that like having stars the way they've naturally sort of formed in the galaxy is not efficient enough for their uses, so they move stars about. You know, you might find that there's like an array of stars in a weird formation. I don't know. I was getting a bit mad now.
Yeah.
But like, if they have the ability to do it, maybe there's just reasons that we can't think of right now for doing stuff like that, like astro engineering, just like huge.
So that's a Type 2 civilization is when it starts using its star.
Yes.
And then Type 3 is when it starts using
a galaxy.
A galaxy, every star in a galaxy.
Essentially, the technological development, technological advancement enough to harness the power of a whole galaxy. I don't really know what that means, but essentially just like manipulate a galaxy. I think that's sort of the point of it.
Well, so if you imagine human society is around for like 100, 200 million years more, okay? You think how fast things have developed now, and we haven't destroyed ourselves in that time. The possibilities are almost endless. You have no idea what we could or anything could be possible of if it's been around that long.
Yeah.
And so it sounds absolutely batshit crazy that you could even consider that as a possibility to move around stars. Like what?
Yeah.
And to use the entire energy supply of a galaxy. But if you are, you know, even you could be a billion-year-old civilization. Sure, I mean, you just have no idea what that could be. You have to imagine every possibility if it's possible to imagine.
Yeah.
Because there's just no way of knowing.
And as they understand more about like the physical universe, and they'll understand more about how to control the physical universe, and like why not do that if they can find ways of doing it to benefit their civilization? Like why not do it? But the thing is,
and you could detect that, right?
You'd be you would imagine it'd be very easy to detect a civilization that is like impacting nature on the scale of a galaxy, right? That would be obvious from a long way off.
Yeah.
And there's some people who've like done like surveys of like 100 million closest galaxies, and no evidence for Kardashev Type 3 civilizations. To like write that off, you know.
And that's, I mean,
who knows really?
Yes.
Like we're just using our like our current understanding of things now to try and extrapolate, but there might be like a step change or something that stops the civilization going to that point.
Yeah, you just have to imagine every possibility.
Yeah.
I think there are actually there's Type 3, but people have added stuff on.
Oh yeah.
I think there's 1, 2, and 3. I think are his original ones.
Yeah. But
I think people have added like a 4th, a 5th, and possibly a 6th.
What? So these get into like
stupid mental stuff. So the 4th one I think was using the entire energy supply in the universe.
Right.
Okay.
So that's Type 4.
So that's Type 4.
So that's one step above 3.
Yeah.
Nice.
So Type 5 is using the energy of multiverses and controlling them and kind of basically using lots of different.
Yeah.
And then I think 6 is a civilization that moves basically out of space and time.
Mm-hmm.
And just you know, it's no longer constricted by time as its dimension. The one that we're kind of
that's an idea that's explored in like bits and pieces of sci-fi and stuff.
Don't spoil.
I'm not going to spoil. Just bits and pieces of sci-fi.
Just naming what we're thinking of would spoil it.
It would. I'm not going to do that.
Yes.
But it's not the only thing. There are other things that it pops up in, like various bits and pieces of sci-fi. So yeah, who knows? I mean, that's not the kind of thing that we'd be able to detect with like radio signals or whatever.
No, but like, well, I mean, if something had taken over the universe, you'd probably notice it.
Well, maybe that's happened. Maybe you wouldn't. Yeah. Who knows?
And these sort of things are going to be anyway. But so the chances are it's going to be what I'm kind of guessing is that if we find another civilization, it's going to be either somewhere close to us in a kind of a technological sense, in that they're you know not too far ahead or whatever.
Yeah.
Or they're very far ahead, but they haven't like taken like they're not able to move stars and stuff.
Yeah.
But they're still significantly more advanced than us.
Yeah.
So I guess they could have things like you could look for like giant computers and all these kinds of things that we talked about.
Yeah.
AIs could be, for example, an AI could be running them.
Yeah. In fact, it almost makes more sense to think about looking for AIs.
Yeah.
You know, it's maybe space. Because it takes so long to travel from like between stars and stuff. If you think about a spacefaring civilization, maybe like AIs are the aspect of that civilization that is going to be doing the spacefaring. So like the people will just be sort of like messing around on a planet having fun.
Yeah, just getting some feedback from some probe thing that keeps multiplying or whatever.
Yeah. So maybe that's a thing to be looking for.
Yeah. So on that topic as well, the other way we could potentially find something is to find like and this is so unlikely, like an artifact.
Yeah.
So something that's been drifting in space
Like the Voyager probes.
Exactly like the Voyager probes. Yeah. That would have to be. That would be the most fortuitous thing.
Yeah.
And is not really probably taken seriously.
I mean, if we found something like that, I think that would, like the chances are it would have come from somewhere close, probably. I mean, right? Like,
yeah.
Just because of what are the chances of like a probe flying through the solar system? I mean,
basically
minimal.
none.
Yeah.
Unless they've been sent here, of course.
Yeah.
Like you're saying, the AI probe. But I suppose I'm talking about something that's just kind of drifted from.
Yeah, like the sort of like Voyager.
Say a civilization that died out billions of years ago, and it just floats through. It just happens to float through because there are quite a lot of these things that happen to float around that have been on missions at some point.
Yeah. That's the cool thing. I mean, we've done that. We sent Voyager out. So like in like
exactly, yeah,
like billions of years time.
Yeah.
A civilization could find that.
Yeah.
And be like, what the hell is this?
Yeah. I mean, chances are it's going to get sucked into a star or something before that.
Yeah, that's almost certainly going to happen. But can you imagine? And it's got that plate on it with the engravings and stuff.
Yeah.
Like, imagine finding something like that. They probably would have. They'd be able to tell it was from a civilization, but they wouldn't really be able to comprehend like the pictures and stuff on it.
Yeah.
I don't know. I mean,
if the aliens can see the pictures.
Yeah, exactly. It might not even like vision and stuff might not be something they're familiar with. But yeah. So
I guess the final thing of like detecting stuff is that if they're already here, we might like is the kind of thing is like. I mean, it's possible.
Like getting angry at red lights or whatever it was last week.
Well, I don't mean in that sense. I sort of mean, in the sense that they know we're here and they're deliberately avoiding us.
Yeah, right, sure.
There's not much we can do about kind of doing that until they deem us ready to know things.
Yeah, I mean, this is something that we can talk about more when we talk about the Fermi paradox in a minute. Yeah. But that is like a thing, like the zoo hypothesis or whatever.
You can't really... That doesn't really count, I suppose, in like looking for something. Like, you're just kind of screwed with it.
Yeah. It's also almost impossible to like test scientifically. Like you can't really get any information out of that. It's like, right, maybe that's happening. Maybe there's a god. You know, like who knows?
Yeah, who knows exactly.
But it's something you can't rule out.
Yeah. So I guess another way we're looking for stuff then is broadcasting our own stuff out.
Yeah.
So as in we talked about the like radio sphere, but like there have been like specific broadcast messages, haven't there?
Yeah, like Arecibo.
Yes. And there was another one I heard of somewhere. It was in the Ukraine or something. They sent it out. It was sent at one of the stars that had an exoplanet discovered around it.
Okay. Well, recently.
Begins with G.
Gliese or Gliese. I can't remember. I know what you mean. GLIESE.
They sent some. It was part of the breakthrough thing.
Was it?
Yeah, it was a breakthrough message.
Shit. This is recent.
Yeah, I think.
Must be.
I think it was like 2008 they sent it out.
Okay.
Fair. I think it was called Breakthrough Message. I can't remember.
What was the message?
Was it that? No. I'm thinking of something else. I think I'm thinking of something else. I think it's called like a message from mankind or something like that. It was a message basically that went out to that particular system. Okay.
Right.
And it just had some stuff in it. But the breakthrough, there is a breakthrough message thing as well. And I forget, I might be conflating two stories here. But the breakthrough message thing was interesting for one reason. So that's like a breakthrough initiative to send out a message, and they were basically giving away a prize for like who came up with the best stuff, and they had a debate with a bunch of scientists to try and work out and decide what they should do and how they should put it, and apparently half the scientists there were against sending a message at all.
Yeah, that's
half
crazy.
of them though.
That's crazy. Oh wait, half of them. Mad. I mean, I know that it's like a few people are quite outspoken saying that we shouldn't send messages out
because it's dangerous, because we might attract the wrong type of alien.
Yeah, of civilization. Or rather that we can't be sure that it's not dangerous.
No, we can't. No.
So whilst we can't be sure, like we should stay silent. I mean, we're not staying silent anyway. There's loads of signals pissing out of the Earth all the time.
I know, but these things are going to be so that they're sending out like very, very strong, concentrated like radio broadcast signals to particular points.
Yeah, and these are like specifically meant for contacting.
Yeah, so they would be more easily detectable by other civilizations. So
half that is actually quite incredible.
Apparently, it was a real struggle to get like it okayed at all.
Wow.
By the group.
I would have thought that most scientists would be up for it. Like, would you be up for it if you were like on a panel of people?
Yeah, I would. Yeah,
I'd be fucking pushing that button myself.
Push the button, send. Yeah, I would be. Although I did pause for a second there and think, is it just me getting excited, or is this like a really, really fucking bad idea?
it is possibly a really bad idea. I think there is actually an argument that it is a really bad idea, like a decent argument. I just don't know if I could get over my excitement.
But who? If you're not gonna try and send out and contact other civilizations and just no, it's too scary. It's sort of like you never would have left your house when you're a kid because it's scary outside because there's a chance you might get run over by a car. Like, fuck that shit. Like, contact them. Try and get that's surely the point of being here.
Yeah. Although you could say that, like, let's listen. Like, let's not actually actively broadcast our presence. Let's just watch.
Well, yeah, you could.
But then you wouldn't learn as much. Like, you could,
and you're just increasing your chances of doing it if you broadcast stuff, I guess.
Yeah.
And
it's like your analogy about, like, sitting in your house when your kid just looking out the window as opposed to, like, going out there and, like,
seeing what
it's like.
Sort of
climbing up stuff and jumping down whatever.
Yeah.
I don't know.
Yeah. Running away from paedophiles.
Yeah.
Just other scary stuff.
Paedophile aliens. That's
what
the scientists are worried about.
There's probably going to be. We've got to find a story about that for the.
Yeah, I mean, they blatantly are like abduction stories.
We can't go off down this tangent.
Okay, all right. So the Arecibo message was that was the other big one. Like, I can't remember when it happened. I'm not even going to make it up. I'm not sure. A few decades ago, whatever.
They sent it out with the Arecibo.
Yeah, with the Arecibo telescope, that beast thing, like in Central America or wherever it is.
Yeah.
Like, huge thing that the Chinese are now trying to trump.
The Chinese are building a massive one.
Absolutely massive. Have you seen you must have seen the pictures of it. It's fucking huge.
Yeah. The Arecibo one looks like kind of janky as well now because it's kind of like there's crap in it in the bottom of it. It's all like muddy and it's kind of just how long has it been there? Like 30, 40 years, something like that.
Yeah, at least. Yeah, a long time.
The Chinese one's like brand spanking new, this gleaming white bowl. That's pretty cool.
They are fucking cool things.
Yeah, they are really
massive,
cool.
like hill-mounted telescopes. But anyway, so they beamed this message out with the Arecibo telescope, and it was like just a binary representation of, like. So I don't know how it was structured or anything, but if you go to the Wikipedia page, there's actually like a graphical representation of it, and it's stuff like the double helix of DNA and and humans, and then something to do with. Like our distance from various pulsars and things, a bit like the Voyager stuff. I mean, it's very similar to the Voyager stuff,
which has
the Voyager plaque.
I just want to make a note here. The recordings they put on Voyager, they're fucking shit.
Fucking shit. Yeah, I totally agree.
It's like the worst bunch of recordings I've ever heard.
It's like people like sneezing and like shutting door. I mean, it's just really just bizarre crap stuff.
I guess what else do you put on there though? You put talking on, and then they're not going to understand it. Although you
definitely want to put some talking on. I mean, they probably did, right? They probably put some talking on. There's music on there for sure.
There is music on there. I guess it's just a sort of sounds of Earth, isn't it? But like,
surely when you want to encode some information into it though, rather than just like a bunch of crap.
Something useful. Yeah, it's just a load of shit.
Can you imagine like a civilization spending like centuries of like the best like science that they could produce trying to decipher like a sneeze, thinking that it's like a packaged short burst of information,
isn't it? I mean, it's cool to think like we're giving them a sample of another world, like the sounds of another world is what they're going to be getting, but actually it's just going to be massively confusing. They're going to waste a load of time trying to decipher what is essentially just noise.
Yeah, it's just people like farting or sneezing or whatever. That's probably not.
Just putting a recording of someone going to the toilet on it. This is someone being sick.
This is someone brutally hungover.
So I think that kind of closes our
part the various ways of in which you might detect aliens.
Yes.
Civilization.